Let me start with something I have noticed over the years. Most people can rattle off derivatives like pros. About the derivatives of x to the power n, tangent x, e to the power x, and so about the product rule, the chain rule, the quotient rule, all of it. But ask them a simple question, what is differentiation? Suddenly everything freezes, they hesitate, fumble, and all that knowledge seems to evaporate. So let us talk about in plain language. What exactly is differentiation? Is it a trick, a procedure, some magical simplification? Or does the phrase rate of change immediately pop into your mind? Differentiation is one of the most powerful ideas in all of mathematics. Yet many people struggle to explain what it actually means. In this short presentation, we will understand differentiation in the simplest, most natural way using just example of a square. But first, why rate of change matters? Everything around us is constantly changing. Objects move, areas grow, temperatures rise, currents flow. To understand any changing quantity, we need to know how fast it changes. That is exactly what differentiation seeks or measures. The rate of change at a particular instant. Let's start with the simplest continuous example. Take a square with side length x. Its area is x squared. Now increase the side slightly by a very small amount, say h. The new side becomes x plus h. And obviously the new area becomes x plus h whole squared. Now the change in area is the difference between the new area and the original area. That is x plus h squared minus x squared. On simplification, this becomes twice xh plus h squared using binomial formula. This represents the thin strip of area added around the square. And the change in side length is simply h. So what is rate of change? To find how fast the area is changing with respect to the side length, we divide the change in area by the change in side. That gives us twice x plus h. This is a rate of change, but it still depends on h. So it is not yet the instantaneous rate. Now we let h approach 0. Now imagine making h smaller and smaller, so small that the bigger square almost perfectly overlaps the original one. As h approaches 0, the expression 2x plus h approaches 2x. This value 2x is the exact rate of change of area when the side length is x. This process, taking two close values, finding their difference, and dividing by the change in input, and then letting that change shrink to 0, is the sense of differentiation. Formally, we write it as the limit of f of x plus h minus fx divided by h as h approaches 0. This limit is called the derivative. The prerequisites here is function should be continuous at x and the above limit should exist. Why derivatives matter? Derivatives appear everywhere in nature, in motion, in circuits, in fluid flow, in planetary orbits. Even the behavior of LEDs and mobile chargers is governed by differential equations. Understanding derivatives means understanding how the universe behaves. Derivative is the language of nature. Thank you for watching and don't forget to like and subscribe.